Hi everyone. So let us discuss verify of Rolle's theorem of a function. We have a given function 2x cube plus x square minus 4x minus 2, and we have to check this function is satisfy the conditions satisfy Rolle's theorem on this given interval, closed interval of minus root 2 to root 2. Okay, so what the Rolle's theorem says? Rolle's theorem says if a function f is defined on a given interval, closed interval ab, and it should satisfy following three conditions, that it should satisfy f should be continuous on the closed interval of ab. The second point, f should be differentiable at open interval of ab, and at the two end points of the interval the values of the function will be equal, that is f of a is equals to f of b. Then there exists a point c belongs to the open interval of ab. There exists a point c belongs to the open interval of ab such that functional differentiation of the functional value at c gives the value 0. Okay, so this is our how the Rolle's theorem states. Okay, so we have to verify that this function satisfy the conditions of the Rolle's theorem, and we have to find this c at which the functional differentiation is 0. Okay, let us see. So this you can see this function is a polynomial function. So as we know, polynomial function is always continuous and always differentiation. So our first two work is done. So let us formally write them as polynomial function is always continuous. So that implies the function f of x is continuous on the interval minus root 2 to root 2. Okay, this closed interval. Okay, this is also differentiable as polynomial functions is always differentiable. So that implies f of x, here the f of x 2x cube plus x square minus 4x minus 2 is also differentiable on, this is open interval. Okay, in Rolle's theorem we required only open interval. Okay, so this is also differentiable on this. So the first two conditions are satisfied. So the next condition is we have to verify at the two endpoints the functional value at these two endpoints are equal or not. So let us see, find f of minus root 2 for this endpoint. So let us check. I will put in the place of x as minus root 2. So 2 minus root 2 cube plus minus root 2 square minus 4 root 2 minus 2. Okay, so 2 minus root 2 cube is minus 2 root 2. Okay, and this is our 2, and this is minus 4 root 2, and this is minus 2. Sorry, this is minus root 2, so this will be plus 4 root 2. Okay, and this is minus 2. So this is nothing but 4 root 2 minus 4 root 2. This is plus 2 plus 4 root 2 minus 2. This plus minus cancel, this minus plus cancel, so we will get 0. So the value of f of minus root 2 we get, this is 0. So I am removing this part. there is no space to write. So let us calculate now f of root 2. I will put root 2 in the place of x. So let us see 2 root 2 cube plus root 2 square minus 4 root 2 minus 2. So let us see here, root 2 cube is 2 root 2 plus root 2 square is 2 minus 4 root 2 and this is minus 2. So this is 4 root 2 plus 2 minus 4 root 2 and this is minus 2. Plus minus cancel, minus plus cancel, so we will also get 0. So what we get here, we get f of root 2, value of f of root 2 is equals to f of minus root 2. So this is what the condition, the third condition of the Rolle's theorem says. So we have proved that f is continuous on this interval, f is differentiable on the open interval of this, and also we have proved that f of root 2 is equals to f of minus root 2. Then so this function is satisfied all the conditions of Rolle's theorem. So there exists on C, as this satisfy all the conditions of the Rolle's theorem, so there must exist on C, so that implies there exist, and C belongs to open interval of minus root 2 to root 2 such that f dash C is equals to 0. So actually what is this? How we will calculate C and how we will see this is an extreme point. So let us see, we have to calculate first f dash of x. So let us see f dash of x. This is 6x square 2x minus 4. This is what our f dash of x. 6x square 2x minus 4. And now we will to find the value of x at which point this is satisfied. So we will equate this as 0. So normally how we calculate in the function of one variable maxima, minima and the extreme values of the function, like this we will equal or we will equate the first derivative of the function to 0 and calculate the value of x. Okay, so all the divisible by 2, so I am simplify this, 3x square plus x minus 2 is equals to 0. So the product is minus 6 and sum is 1. Product is minus 6 and sum is 1. So I will divide this as 3x minus 2x minus 2 is equals to 0. So take 3x as common, so x will leave here and plus 1, and here take 2 as common and x plus 1. Okay, and 3x minus 2 multiplied with x plus 1 gives 0. So either 3x minus 2 is equals to 0 or x plus 1 is equals to 0. So 3x is equals to 2, so x is equals to 2 by 3 or x is equals to minus 1. So clearly you can see we get two values for C, x equals to 2 by 3 and x is equals to minus 1. So these 2 points will satisfy our this equation. So C is that 2 points, 2 by 3 and minus 1. You can see 2 by 3 and minus 1 belongs to this interval. belongs to these 2 points belongs to root 2 minus root 2 root 2. These 2 points belongs to these 2 interval. So clearly this function satisfied the Rolle's mean value theorem on the given interval.